Hey there, you remember this? Yeah, it's the difference quotient. Do you remember when we covered this year? It was all the way back in chapter 1 when we talked about evaluating functions. And it seemed sort of random at the time, and it's going to seem a little bit random here. But what I want to do right now is I want to have us find a limit of this difference quotient. Way back when we discussed this, I said, I promise you this won't make too much sense right now, but it'll make more sense when we get to the calculus portion of our course. Well, we're there. And I'm going to ask you to hold on a little bit longer because right now all I want to do is do a little bit of the heavy lifting and working out the algebra here and figuring out how to actually find the limit of the difference quotient. And I promise you, in the next video, I'll actually talk about the significance of this and how this actually becomes a huge building block for the foundation for a lot of the calculus we're going to study. But for now, let's just actually practice finding the limit itself. So let's find the limit of the difference quotient specifically as h approaches 0. Let's find the limit of this as h approaches 0. Well, think about what's happening here as h approaches 0. As h gets closer and closer to 0, and you can even think about this using direct substitution if it makes it easier. If h is equal to 0, then we can say this is equal to the limit as h approaches 0 of, if h is 0, then all that's left up here is just f of x. And we're subtracting another f of x. And if we have h is equal to 0 down in the denominator, well, think about what we have there. Oops. Well, this would just be equal to, or we would end up, I should say, with 0 over 0 or some indeterminate form. And this is not a mistake. This is what we're supposed to be getting. I'm trying to highlight that if we try direct substitution right now with any difference quotient as it is, you'll end up with indeterminate form. But as we discussed at the beginning part of 11.2, we have some techniques for evaluating limits, and we're going to apply them here as we practice finding the limit of some difference quotients. Okay? So let's try this in an actual function. So let's go ahead and look at this first one here. And don't let the fact that the constant is at the beginning here fool you. We've just got some quadratic function, and we are going to find the limit of this function's difference quotient. Okay, so stretch out your hands because we're going to be doing some writing here. All right, so let's take a quick look. We've got the limit as h approaches 0 of the following. And let me just zoom in on this a little bit. The limit as h approaches 0 of the following. And I'm going to have to probably use some colors here. So let's go ahead and just use blue for this portion. Let's look at what does f of x plus h give us? Or what does that look like? And all that means is we are going to evaluate this function for x plus h. So what is f of x plus h? Well, we get the following. 4 minus 2, and we're going to replace all of our x's with x plus h. So x plus h minus x plus h squared. All right, so there's our f of x plus h. Now, we're going to subtract now what f of x is. And let me use red to highlight what I'm about to write is our f of x. Well, what is f of x here? Being really careful with our parentheses. F of x is just this right here. So we've got 4 minus 2x minus x squared. And all of this is over h. All right, so we're going to need to expand this out. Sometimes in order for you to clean things up, you've got to make things a little messy first. So we've got 4 minus 2x minus 2h minus x squared minus 2hx. Be careful with your signs. Remember, you're distributing a negative each time. Minus h squared minus 4 plus 2x plus x squared. And all of this over h. All right, so if you know me, you know we're just about to do my favorite thing in all of math, and that's simplify. So what can we have negate one another? We've got a positive h, positive 4, negative 4. We've got a positive 2x and a negative 2x. We have an x squared and a negative x squared. And is there anything else I can clean up right now in just the numerator? And the answer is no. So let me actually clean this up first, even though I do see something that I can do in just a moment. So we've got negative 2h minus 2hx minus h squared. And all of this is over h. Well, and hopefully you see it now too. I've got an h now in the numerator and the denominator that I can divide out. So I'm going to divide this h with this h, that h, and one of those h's. So if I clean that up fully, I've got the following. And let's show it right. Negative 2 minus 2x minus h. So now let's see if we still get indeterminate form if we find the limit of this. The limit of this statement as h approaches 0 would be just negative 2 minus 2x. So here is the limit of our difference quotient for this function. And again, I promise you, in 11.3, I will explain the significance of all this. All right? Right now, we're just practicing finding the limit of the difference quotient. Let's do one more. Okay, let's try this problem now. We're going to find the limit of this difference quotient for this particular function. So we're going to write the limit as h approaches 0. So again, just to help out, I'm going to use some colors here. Let's find f of x plus h. So f of x plus h is just evaluating this function at x plus h. So we're going to replace all our x's with x plus h. So we've got the square root of x plus h minus 2. Okay? Minus. Now whatever f of x is, we've got f of x, we're going to go minus x minus 2, because f of x is just equal to that. And, oops. Wow, I had no idea I even had these colors. This is a literal breakthrough for me. All right, I'll play around with that later. All right, all of this over h. Okay, so if I try to plug in h right now, and maybe mentally you can just see what's going to go on, but this right away, the fact that we have just as h in the denominator is a bit of a giveaway that I might end up with indeterminate form. So, because I don't want to spend the time even doing that, I'm going to go ahead and use one of the techniques we talked about at the beginning of 11.2, and we're going to multiply by the conjugate here. So again, hang with me, it's a bit of writing, but x plus h minus 2, this time plus x minus 2. That's the conjugate of the entire numerator. And this is going to help me negate a lot of these radicals. X plus h minus 2 plus the square root of x minus 2. And here we go. We've got, this is just a difference of squares. Even though it looks a little daunting, it's just a difference of squares. So we've got all of x plus h minus 2 minus all of x minus 2. Be careful with your parentheses again. Over h times the quantity of still square root of x plus h minus 2 plus root x minus 2. And before we think about distributing that, let's just clean that up a little bit further. And if it helps out, let's just go ahead and get rid of some of these parentheses right now and distribute that negative while we're at it. So let's minus x and make that plus 2. So all I did was just distribute that negative. Now, is there anything I can clean up here? Well, I've got an x and a negative x, and I've got a positive 2 and a negative 2. So all that's left over is an h in the numerator, and that's exactly what I needed, because now I can divide out that h in both the numerator and denominator. And what we're left with, let's just clean that up, is 1 over the square root of x plus h, I'm probably going to need a little bit more, x plus h minus 2 plus the square root of x minus 2. And the fact that that h is now gone is pretty good sign that we'll probably be able to find our limit here without resorting to or getting indeterminate form. So if we plug in 0 for h here, we're left with 1 over the square root of x minus 2 plus the square root of x minus 2. And if I just clean that up, that just gives me 1 over 2 times the square root of x minus 2. So again, here's the limit of this difference quotient. You can also rewrite this as 1 over 2 times x minus 2 to the negative 1/2. And heck, if you wanted to rationalize this even, you could get root x minus 2, 2x minus 4. All right. Again, right now we're just doing a process without really understanding what exactly this means, but that's why you're going to click on